In this video, I'm going to talk about trig modelling and how we're going to use a variety of skills about periodic functions to be able to solve a problem. Now, I've written up a problem very shorthand, but I do have the problem in a piece of paper on my hand. So pretty much what we're dealing with is a trawler. Trawler needs to come into the harbour, and the tide or the height of the tide is modelled by this equation up here. What we want to know is, well, first of all, what is high tide? What's the height of high tide? And when does it occur in the first 24 hours? We want to know the difference between high and low tide. We want to sketch the graph. I'll talk about that in a moment. And then we want to know, well, if John can bring his trawler in only at a height of 6 metres, how long has he got, or what times can he bring his boat into the harbour when it's safe to do so? So what I'm going to do is I'm going to talk about the sketch. Before you try a problem like this, it's a good idea to have a sketch, whether that be by hand or on the calculator. So I'm going to just make some sketches of this. So in order to sketch, we notice that the value of d, it's a cos function, the value of d is 5. So our equilibrium position will sit at 5. The amplitude is 2, and there has been a change in period, no horizontal shift. So let's have a look at the period first, because that's the thing that I'm going to need to calculate. So don't forget, our period is calculated by 2 pi over b. Our value of b is pi upon 6. So we're going to do 2 pi divided by pi upon 6. Knowledge of fractions, working that out is the same as saying multiplied by 6 over pi, which gives you, pi's cancel out, you end up with 12. So our period is 12, and we're dealing in hours. So I'm just going to draw up a quick sketch so that we can look at that sketch and try and solve some problems. Alright, so let's have a look at what is high tide and when does it occur. Well, we can see this from the graph that we've sketched straight away automatically. We can see that high tide is 7 metres, because remember our equilibrium position was 5, the amplitude is 2, so 7 metres is our high tide. When does that happen? We can see it happened at the beginning, 0 hours, 12 o'clock, so 12 hours later, and then at 24 hours, a further 12 hours after that. Now, if you don't have a sketch or no means of having a sketch, there's ways you can do this. To find the maximum value that this function can take, cosine, you can simply substitute the whole of this angle. The maximum value that the cosine function can take is 1. So that if you substitute all of this for 1, 1 times 2 is 2, plus the 5 is 7. So that's one way you can work it out. Let's have a look at when it's going to happen. Well, to establish when it's going to occur, you've got to solve this trig equation for when the height is equal to 7. So let's do that. So a 7 equals 5 plus 2 cos pi t over 6. Well, subtract the 5 first. 2 equals 2 cos pi t over 6. Divide by 2. 1 equals cos. Now I'm going to do a substitution here for all of this. Let's just say the value of cos theta has to equal 1. I can work this out later. Let's just write down that we're doing a substitution here. Now, on the unit circle, because I'm going in the first 24 hours, that's 2 periods. Remember, we worked out earlier that one cycle around the unit circle was 12 hours, and we want the first 24 hours. So we will need to go twice around that unit circle. So when does cos theta equal 1? Well, that's a boundary angle. If we look on the unit circle, we know that here is the coordinate, the 1, 0, half asleep, 1, 0. So we know that that occurs at 0, at 2 pi, and at 4 pi. So if I then solve that for this, so we go 0, first of all, is our first time, pi is our first solution on there, over 6, well, that gives you t equals 0 when you solve. The second one I said was 2 pi. What's the round here? 2 pi is equal to pi t over 6. Solving that, 12 pi equals pi t. Divide by pi, t equals 12. So 12 hours is the next time, which we can see from the graph. And then the last solution was 4 pi. So 4 pi is equal to pi t over 6. 24 pi equals pi t. So therefore, t equals 24, which is what we can see from the graph. All right, the difference between high and low tide. Well, if high tide is 7 and low tide is 3, the difference between them is 4 metres. Now let's have a look at this John. John bringing his boat in. It's only safe to do so when the boat, or when the high tide is at, when the tide, apologies, is at 6 metres. Well, looking at our sketch, 6 metres is somewhere in between here. So if I was to draw a dotted line, we've got an idea of how many solutions we're going to get in the first 24 hours. There's a solution here, a solution here, here, and here. However, what does this mean with regards to the problem? We want the height to be above 6 meters. So he's safe to bring his boat in any time between naught and this time, whatever that may be. Any time from here to this time, and whatever those times may be. And then again, from this time onwards to the next one, which will then come back here on the next day. So let's clear some space and let's show you how to solve that. All right, so I've cleared the space. So now what I'm going to do is solve it so that 6 is our height and work through the procedures of solving an equation to solve for t. So subtract 5 from 6 is 1 equals 2 cos pi t over 6. Now I'm going to divide by 2, I get 1/2. And I'm going to substitute pi t over 6 for theta again, because then I can do my solutions later on. So let's just say we have let theta equal pi t over 6. All right, remember we're dealing with the first 24 hours. So that's twice around the unit circle we need to go, and we've established that. So when is cos theta 1/2? Well, 1/2 is our exact value. Remember, it's of one of our special triangles, pi over 3, or 60 degrees. But when you're doing problem solving, you always work in radians. So we're dealing with pi upon 3. Our special triangle is 1/2, because cos is adjacent over hypotenuse. So it is pi upon 3. So we need to establish if that is our first solution. So let's just write that theta equals pi over 3. Let's go across. Let's note here that cos is positive here. 1/2 is a positive value. Go across to our unit circle. Where in the unit circle is cos positive? Well, it's positive in the first quadrant and it's positive in the second quadrant. So because pi upon 3 is in our first quadrant, it is our solution. So it's first solution for the angle. Remember, that's not our time. We haven't done that yet. Let's go through twice around the unit circle and find the 4 angles. So the second time round is going to be 2 pi take away pi upon 3. So 2 pi take away our pi upon 3. 6 take 1 is 5 pi over 3. Then we keep going round the unit circle at 2 pi plus pi upon 3. So our third solution, let's go over here. Third solution is 2 pi plus pi upon 3. So 6 pi plus 1 pi upon 3 is 7 pi upon 3. And then finally, our last solution as we keep going round is 4 pi take away pi upon 3. So I don't think I'm going to fit that down there. So I'll write it here. Theta 4 is 4 pi take away pi upon 3, which is 11 pi over 3. Now it's just a case of solving for t for each of those. So let's look at the first one. So I'm going to substitute theta into this equation here to solve for t. So let's just draw a line here. So theta 1. So theta 1 is pi over 3, which is equal to pi t over 6. Moving this around, we get 6 pi over 3 pi equals t. So 6 over 3 is 2. So our first time is at 2 hours. Let's keep going through. We're going to multiple. I'm going to solve for this one. 5 pi upon 3 now. I'll just do one more and then I'll just write the solutions up. 5 pi over 3 is equal to pi t over 6. So 30 pi over 3 pi is 10. So the time is 10 hours later. So if we look at the graph, this is now 2. This is 10. Interpreting my answer, if I keep going through, I can just give you that that's 14 there. And the last time is at 22. I've just had a look at my paper. Now let's interpret that answer. You should always interpret when you do modelling and problem solving. So we can say John is okay. He's clear to bring his trailer in the first 2 hours. He can then bring his trailer in sometime between 10 a.m. and 2 p.m. because assuming that this is midnight. Then we can then say he's safe to bring his trawler in from 10 p.m. at night till 2 a.m. the next day. And that's pretty much all you need to know about problem solving.